Today we're going to discuss integration using substitution method. So I will be discussing several examples for you to understand how to solve using substitution method. For number one, we have the integral of 1 minus 1 over x cosine of x minus ln x dx. So our u here is, let u here is equal to x minus ln of x. So du now equals 1 minus 1 over x dx. Since 1 minus 1 over x dx is visible in the given, so we can rewrite now the given in terms of u and du. So they start now with cosine of u, and then 1 minus 1 over x dx is equivalent to du. So that the integral of cosine u du is sine u plus a constant. So replacing the value of u, so we have sine now of x minus ln of x plus a constant. For number 2, we have the integral of 3 times 8x minus 1 times e raised to 4x squared minus x dx. So let our u be equals to 4x squared minus x. So take the derivative of that. That is now 8x minus 1 of dx. So our du is visible in our given. So therefore, we are going to rewrite now the given in terms of u and du. So I can write now 3 times e raised to u times the meaning now of 8x minus 1 dx is equivalent to du. So writing 3 as the constant multiplier, so we have 3 times the integral of e raised to u du. So taking the integral now, we have 3 e raised to u plus a constant, and 3 times e raised to 4x squared minus x plus a constant. For number 3, we have the integral of x squared times 3 minus 10x cubed. So the quantity of that from 3 will be raised to the power of 4. Now, our u there is 3 minus 10x to the power of 3. So the du now will have the negative 30 of x squared dx. So x squared dx is visible in the given. So we have now the coefficient of negative 30. So to eliminate that, we have to divide both sides by negative 30. So therefore, du over negative 30 is equal to x squared dx. Now, we are going to write the given in terms of u and du. So starting u here, we have u to the power of 4 times the meaning of x squared dx is du over negative 30. So now we can have negative 1 over 30 as our coefficient factor times u to the power of 4 of du. Then evaluating that one, integrating this one, this becomes now negative 1 over 30 of u to the power of 5 over 5 plus a constant. So multiplying that, we can have negative 1 over 150 of 3 minus 10x to the power of 5 plus a constant. For number 4, we have the integral of x over the square root of 1 minus 4x squared dx. So our u here is 1 minus 4x squared, and du now equals negative 8x dx. Since x dx is visible in the given, this one, so we are going to define x dx now is equal to du over negative 8. And then rewriting the given, so x dx means du over negative 8 all over u raised to 1 half. So rewriting that one, it becomes now negative 1/8 times the integral of u raised to negative 1 half of du. So integrating that one, it becomes now negative 1/8 times u to the power of 1 half over 1 half plus a constant. So simplifying that one, you have negative 1 over 8 times 2 u raised to 1 half plus a constant. And finally, we have negative 1 over 4 of u is 1 minus 4x squared to the power of 1 half plus a constant. Number 5 is the integral of sine of 1 minus x times the quantity of 3 minus cosine of 1 minus x raised to 4 dx. So our u here is equal to 3 minus cosine of 1 minus x, and then du is equal to derivative of 3 is 0 minus derivative of cosine is negative sine of 1 minus x, and the derivative of 1 minus x is negative 1 of dx. So simplifying that, we can have now the negative sine of 1 minus x times negative 1. It gives us positive sine of 1 minus x. So we have negative outside, therefore du now equals negative sine of 1 minus x of dx. So we can see that sine 1 minus x dx is found in the given. So we have now a coefficient factor of negative 1. So rewriting now the givens, we have the integral of u raised to 4 times negative du. So therefore, we have the negative of u raised to 4 du. So integrating that one, we have negative u raised to 5 over 5 plus a constant. And replacing the value of u, we have the negative 1/5 of 3 minus cosine of 1 minus x, and then plus a constant. For number 6, we have the integral of cosine 4x sine to the power of 10 of 4x dx. So our u here is equal to sine of 4x. And then the derivative of that, we have 4 cosine of 4x dx. So cosine 4x dx is visible in the given. So therefore, we have a coefficient factor of 1/4. So the coefficient factor 1/4 can be obtained by dividing both sides by 4. So that's why we have du over 4. Or in short, we have coefficient factor of 1/4. So rewriting now the given, I can have 1/4 of the integral of u raised to 10 du. So we have now 1/4 of u raised to 11 over 11 plus a constant. So multiplying that 1, 4 times 11 is 1 over 44, and the meaning of u is sine to the power of 4x to the power of 11 plus a constant. Or it could be written as 1 over 44 of sine to the power of 11 of 4x, and then plus a constant. In number 7, we have the integral of secant squared 4x times the quantity of 3 minus tangent of 4x to the power of 3. So in this case, our u is 3 minus tangent of 4x. So taking the derivative of that, we have now the derivative of 3 is 0 minus the derivative of tangent is secant squared. So we have the negative of secant squared of 4x times 4 dx. So simplifying that one, we have now negative 4 secant squared of 4x dx. So secant squared 4x is visible in the given. So therefore, we are going to divide both sides by negative 4. So we have now du over negative 4 is equal to secant squared of 4x dx. So by rewriting now the given in terms of u and du only, therefore we have the integral of u to the power of 3, and the meaning now of the underline given there is times du over negative 4. So we have now negative 1/4, the integral of u to the third power of du. So integrating that one using the power rule, so we have negative 1/4 times u to the power 4 over 4 plus a constant. So simplifying that one, we have the negative 1 over 16 of the meaning of u is 3 minus tangent of 4x to the power of 4 plus a constant. In number 8, we have the integral of 3x over 5x squared plus 16 of dx. Since there is an x in the numerator, so we are just going to find u as 5x squared plus 16, and du is equal to 10x dx. So x dx can be found in the given. So therefore, we're going to define x dx by dividing both sides by 10. So therefore, x dx is equal to du over 10. So by substitution, I will write first 3 as outside the integral sign. That's just a constant multiplier. So 3 times the integral of x dx means du over 10 all over u. So therefore, we have 3 times the coefficient factor here is 1 over 10. So that becomes now 3 over 10, the integral of du over u. So integrating that one now, we have 3 over 10 ln of the absolute value of u plus a constant. So finally, we have 3 over 10 ln of the absolute value of 5x squared plus 16 plus a constant. In number 9, we have the integral of 3 over 5x squared plus 4 dx. Since there's no x variable in the numerator, so there is a possibility that we are going to use the inverse trigonometric function. So if that's the case, I'm going to pick up u squared. So u squared now is equal to 5x squared and a squared is equal to 4. So from u squared is equal to 5x squared, so we can have u now is equal to the square root of 5 of x, and a now here is equal to 2. So we have here, we can take the derivative of u now, so du is equal to the square root of 5 dx. Since dx is there, so we will just find dx as du over the square root of 5 is equal to dx. So by rewriting now the given in terms of u du, so I can write now as 3 times the integral of dx stands for du over the square root of 5 all over u squared plus a squared. So rewriting that again, so we can now have 3 over the square root of 5 of the integral of du over u squared plus a squared. So this one now will give us a direct substitution to the formula of 1 over a arc tangent of u over a plus a constant. So by substitution, we can now have, we still have constant multiplier of 3 square root of 5 times 1 over a. So 1 over a is 2. Then arc tangent of u now is square root of 5 of x over 2 plus a constant. So multiplying now the coefficients, so we can now have 3 over 2 square root of 5 arc tangent of square root of 5 of x over 2 plus a constant. So in number 10, we have now the integral of 2x cubed plus 1 over the quantity of x to the fourth power plus 2x and then to the power of 3. So our u here is x to the power of 4 plus 2x, and we take the du, that is now 4x cubed plus 2x of dx. So 4x cubed plus 2x can be found only in the denominator if we're going to factor out the common factor of 2. So we have now 2 times 2x cubed plus 1 of dx. So 2x cubed plus 1 dx is now visible in the given. The one that is I highlighted is the meaning of our du, but we have a coefficient factor of 1/2. So dividing now both sides by 2, so we can now have here as du over 2 is equal to 2x cubed plus 1 of dx. So rewriting now the given in terms of u and du. So the meaning now of 2x cubed plus 1 of dx is du over 2 all over u to the power of 3. And now we are going to write as 1/2 times the integral of u to the power of negative 3 du. So we have now 1/2 times u to the power of negative 2 over negative 2 plus a constant. So multiplying that one now, we can have negative 1/4 of the meaning of u is x raised to 4 plus 2x to the power of negative 2 plus a constant. Okay, in number 11, so the integral of 2x cubed plus 1 over x raised to the power 4 plus 2x of dx. The difference between that to the example number 10 is that the denominator has no power of 3. In that case, so we will try again u as x raised to 4 plus 2x. And du now equals 4x cubed plus 2 of dx. So factoring out the 2, we have 2 times 2x cubed plus 1 of dx. So 2x cubed plus 1 of dx can be seen in the given. So therefore, we're writing that one, but still we have a coefficient factor of 2. So we'll write here coefficient factor is 1 half. So to obtain 1 half, we're just dividing both sides by 2. Therefore, it becomes now du over 2 is equal to 2x cubed plus 1 of dx. Or simply write now as CF is equal to 1 half. So therefore, I can write now 1 half times the integral of the meaning now of 2x cubed plus 1 dx is we have du over u. So therefore, we just have 1 half the integral of du over u is ln of u plus a constant. So substituting back the value of u, so we have 1 half ln of x raised to 4 plus 2x plus a constant. Okay, for number 12, we have the integral of x over the square root of 1 minus 4x squared dx. So our u here now is 1 minus 4x squared, and du is equal to the negative 8x dx. So x dx is found in the given. So therefore, dividing both sides by negative 8, we have du now over negative 8 is equal to x dx. So rewriting now the given, so x dx means du over negative 8 all over u raised to 1 half. So rewriting that one, it can be now written as negative 1 over 8 times the integral of u to the power of negative 1 half of du. So therefore, negative 1 half times u to the power of 1 half over 1 half plus a constant. So multiplying that again, that is now negative 1/4 of the meaning of u is 1 minus 4x squared plus a constant. In number 13, we have the integral of 1 over the square root of 1 minus 4x squared dx. So it is quite different from the example number 12, because in number 12, the only difference between number 13 and 12 is that there is x in the numerator for number 12, while number 13, there is no variable x in the numerator. So therefore, there is a possibility that we can use the inverse trigonometric functions of arc sine. So this is now arc sine of u over a plus a constant. So selecting now my a squared is equal to 1, it follows that a equals 1, and u squared now equals 4x squared. So finding u for that, we have now the square root of 4x squared is 2x, and take the derivative of that. So we have 2 dx. So we only have dx, so therefore we define this is du here. So we have to define dx is equal to du over 2. So by rewriting now the given, so we can have here the integral of 1 dx. So dx now means du over 2, and then the square root of a squared minus u squared. So we can write now our coefficient factor as 1 half times the integral of du over the square root of a squared minus u squared. So according to the formula in the inverse trigonometric function, that is now equivalent to arc sine of u over a plus a constant. So since I have 1 half, so I'll write first 1 half, and then arc sine of u. Our u now is 2x, and then our a is 1, so don't need to write because 2x over 1 is just 2x. So therefore, plus a constant. So we have now the answer of 1 half arc sine of 2x plus a constant. So in number 14, we have now the integral of x squared plus 1 to the power of 1 minus x dx. So we can expand our given in terms of the integral of x squared plus the integral of 1 minus x dx, since the value of u there is not common. Okay, so now I'm going to write the integral of x squared dx plus the integral of e raised to 1 minus x dx. So in the first term, it can be easily integrated. So we can write now x cubed over 3 plus, in the second term, we need to use the substitution method. So we let u here is equal to 1 minus x, and du now is equal to the negative dx, or dx is equal to the negative of du. So the integral now of e raised to u times the meaning of dx is negative du. So rewriting now the given, we have x cubed over 3. It becomes now positive times negative coefficient. So we have negative of e raised to u du. So we can now integrate now as x cubed over 3 minus e raised to u plus a constant. So we're writing the meaning of u. We have x cubed over 3 minus e raised to 1 minus x plus a constant. Okay, for number 15, we have the integral of x cosine of x squared plus 1 plus 1 over x squared plus 1 of dx. So let our u be squared plus 1, then du equals 2x dx. So in du, we have x dx. On the first term, we have x dx, but in the second term, there's no x in the second term, so therefore, I'm going to rewrite the given. So first, the first term now becomes x cosine of x squared plus 1 of dx plus the integral of 1 over x squared plus 1 of dx. So I will use u du as substitution method in the first term. So I have now x dx in the first term. So therefore, I'm going to divide two sides. So therefore, du over 2 equals x dx. So rewriting now the first term, this gives us cosine of u times du over 2. So plus the second term, I will just rewrite as 1 over x squared plus 1 dx. So the integration now for the first term will give us now 1 half times sine u plus the integration of the second term is arc tangent of u plus a constant. So replacing now the u, so we can have now 1 half of sine of x squared plus 1, but the u here in the second term is just x. So therefore, arc tangent of x plus a constant. For number 16, we have the integral of sine x times the square root of 3 minus 2 cosine x plus 1 over 5x plus 2. So by observing the value of u in the first term and the two terms are not the same, so I'm going to solve the first term and the second term. So I will just rewrite it first as sine x, the square root of 3 minus 2 cosine x dx plus the integral of 1 over 5x plus 2 dx. So in the first term, our u here is 3 minus 2 cosine of x. So du now equals the negative of negative 2 sine x dx. So therefore, du now equals positive 2 sine x dx. So I can see sine x dx in the given. Therefore, I divide both sides by 2. Therefore, du over 2 is equal to sine x dx. Now, in the second term, I will use other variable aside from u. Okay. In the second term, we let now our v is equal to 5x plus 2. Then dv now is equal to 5 dx. So I can only find there dx, therefore I define dx as dv over 5 is equal to dx. So after letting know u du in the first term and v dv in the second term, so we can now rewrite the given as the integral of u raised to 1 half times the sine x cosine x means du. And in the second term, we have now dx means that is dv over 5 over 5x plus 2 means v. Therefore, this is now the integration of the first term becomes u raised to 3 halves over 3 halves plus the second term now we have 1/5 the integral of dv over v. So therefore, the final answer now will give us 2/3 of u means 3 minus 2 of cosine of x to the power of 3 halves plus 1/5 of the ln of v, ln of v plus a constant. So therefore, we have now 2/3 of 3 minus 2 cosine of x to the power of 3 halves plus 1/5 of the ln of our v now is 5x plus 2 plus a constant. For number 17, we have the integral of 3x over 5x squared plus 16 of dx. So let our u here be 5x squared plus 16. So du now equals 10x dx. So in the given, we have x dx and we also have x dx here. So we can rewrite now the given in terms of u and du, but we need to solve first x dx. So x dx is equal to du over 10. So by rewriting the given, I will write first 3 as constant multiplier, and then x dx stands for du over 10 all over u. So therefore, this is now 3 times 1 over 10 becomes 3 over 10. So the integral of du over u. Now, we have 3 over 10 times ln of the absolute value of u plus a constant. Rewriting the meaning of u, we have 3 over 10 ln of the absolute value of 5x squared plus 16 plus a constant. So number 18 is the integral of 4x plus 3 over x squared plus 16 of dx. So first, I'm going to let u equals x squared plus 16 and du gives us 2x dx. So x dx in the first term can be found in the given, but in the second term from 4x plus 3, so we don't have x there. So therefore, I'm going to expand the given as 4x over x squared plus 16 of dx plus the integral of 3 over x squared plus 16 of dx. Now, applying now u du in the first term because there is x dx in the first term. So I'm going to solve first x dx. So therefore, this is now du over 2. So rewriting that one, I have now 4 times the integral of x dx, which means du over 2 all over u. Plus, on the second term, so I will just write here 3 times the integral of dx over x squared plus 16. So integrating this one now, we have 4 times the coefficient factor is 1 half times, I will just rewrite first du over u plus 3 times the integral of dx over x squared plus 16. Now integrating this one now, we can now have 4 times 1 half is 2 times ln of the absolute value of u plus this one is 3 times we have 1 over a arc tangent of u over a plus a constant. Now let us solve this first. So from the second term, we have u there is equals x and a is equal to 4. So by substitution to the second term, so I can write now as 2 ln of the absolute value of u, which is now x squared plus 16 in the first term, plus 3 times 1 over a becomes 3 over a. Our a now in the second term is 4. Then arc tangent of u over a. Our u there is x in the second term, and a is 4. So plus a constant. So finally, we have now the answer of 2 ln of the absolute value of x squared plus 16 plus 3/4 of arc tangent of x over 4 plus a constant. In number 20, so the given is the integral of e raised to x plus e raised to x dx. If we are going to let u equals x plus e raised to x, then the du now gives us 1 plus e raised to x dx. So 1 plus e raised to x dx cannot be found in the given. So in other words, we are going to do something the given by using the product rule. We can rewrite that one now as e raised to x times e raised to x. So from here, we are going to let now u is equal to e raised to x and du is equal to e raised to x dx. Now, our du of e raised to x dx is visible now in our given. So rewriting this one so that you can see it clearly, that I will rewrite this one as e raised to x times e raised to x dx. So rewriting that one now in terms of u and du, so the integral of e raised to x can be now the integral of e raised to u, and e raised to x dx is now du. So the integration of that will give us now e raised to u plus a constant. And now, replacing the value of u from e raised to u plus c, so will give us now e raised to x plus a constant. So for number 21, we have the integral of 2x cubed times the square root of x squared plus 1 dx. So first, we are going to write our u. U now is equal to x squared plus 1, and du now will give us 2x dx. But we only have 2x cubed dx in our given, and we have here 2x dx. So first, we are going to factor out 2x cubed in a way that we can have a factor of 2x dx. So rewriting the given now, we have x squared times the square root of x squared plus 1 times 2x dx. So x squared times 2x will give us now 2x cubed. Now 2x dx is very clear, that is part now of the given. So we have now the meaning of 2x dx that is equal to du. So, but we have still another extra variable of x squared. Okay, that x squared now can be solved from u is equal to x squared plus 1. Solving for x squared now, it is equal to u minus 1. So therefore, by rewriting now the given, so we can write now x squared as u minus 1 times the square root of x squared plus 1 can be written as u raised to 1 half times 2x dx can be written as du. So by multiplying this one, u times u raised to 1 half will give us u to the power of 3 halves minus 1 times u raised to 1 half is u raised to 1 half. Then the integral of this, so the integration for that now will give us u to the power of 5 over 2 over 5 over 2 minus the integration of u raised to 1 half gives us u to the power of 3 halves over 3 halves plus a constant. So simplifying that, that will give us 2/5 of u is x squared plus 1 to the power of 5 over 2 minus 2/3 times the meaning of u is x squared plus 1 to the power of 3 halves plus a constant. In number 22, the integral of 1 over x ln x dx, so our u here is ln of x. So du now equals 1 over x dx, which is visible now in our given. So let me show you that it's visible because 1 over x dx is now the meaning of du. So we have now the integral of du over u. So we have now the ln of u plus a constant, which is now ln of x plus a constant. So for number 23, we have the integral of e raised to 3x over 1 plus e raised to 3x dx. Our u here is 1 plus e raised to 3x. So the derivative of that is just equal to 3e raised to 3x dx. So we have here e raised to 3x dx. So we will define now e raised to 3x dx is just equal to du over 3. So rewriting the given now, the meaning of e raised to 3x dx is du over 3 over u. So we have now 1/3 times the integral of du over u, which is now 1/3 of ln of u plus a constant. So therefore, we have 1/3 of ln of the absolute value of u, which is 1 plus e raised to 3x plus a constant. For number 24, we have e raised to 2x over 1 plus e raised to 4x. So let our u there as u here is equal to e raised to 2x. And du is equal to 2e raised to 2x dx. So rewriting the given first as e raised to 2x over 1 plus e raised to 2x to the power of 2 dx. Because power to power rule gives us now the exponent of 4x for the e. So we can see that e raised to 2x dx. Now we have to solve now e raised to 2x dx is equal to du over 2. So we can now have e raised to 2x dx means du over 2 all over 1 plus u squared because u here is e raised to 2x. So rewriting that one, we can have now 1/2 the integral of du over 1 plus u squared. So the integral of du over 1 plus u squared will give us 1/2 times arc tangent of u of plus a constant. And our u is e raised to 2x. So therefore, we have 1/2 of arc tangent of e raised to 2x plus a constant. And for this last number, we have the integral of arc sine of x over the square root of 1 minus x squared dx. So our u here is equal to arc sine of x, and the derivative of arc sine of x is 1 over the square root of 1 minus x squared dx, wherein this du now is visible to the given. So rewriting now the given, so we can have now arc sine of x can be written as u times dx over the square root of 1 minus x squared can be written now as du. Therefore, we have only u squared over 2 plus a constant. So rewriting again the meaning of u, we have arc sine of x to the power of 2 over 2 plus a constant.